I'm going to show you now how to calculate percentage of students and standard errors for the different proficiency levels. There are levels that are established in PISA and also in TIMSS and PEARLS. And you can use the PISA bend PV function for PISA, for example, to calculate the percentage of students at each of these levels. Same with TIMSS and PEARLS, we also have TIMSS bend PV function and PEARLS bend PV functions. The arguments are a bit similar to the ones for calculating average performance, so the mean PV functions, because we also have a PV label argument, which again is the label of the plausible values variables. So this was the suffix for PISA. And also we have a cutoff argument, which defines the cutoff points for the different levels. And these are the cutoff points defined by PISA. So you could actually omit this argument if you wanted to calculate percentages for the levels defined by PISA, or you could modify this argument if you wanted to change these levels. We have a grouping variable and our data set. I'm going to execute this line, and you see as an output I get the percentage of students at each of these levels and also the standard errors for the education systems that are included in the dataset. And of course, the standard errors take into account the rotated test forms with the plausible values and the complex sample design with replicate weights. TIMSS, the structure of the function is similar. The label changes. The cutoff points defined by TIMSS are these cutoff points. We could change them if we wanted, or we could omit this argument if we wanted to calculate percentage of students for the levels defined by TIMSS. This is the output again, so you have percentage of students at each of these levels. Same with PEARLS, and now you see I'm not even including the cutoff argument because I want to use the default, which you can see here. The default for cutoff, this is the PISA proficiency level, are the levels defined by PISA, but you could also see the default for PEARLS, which are the levels that the cutoff points that we entered before. So we don't need to actually enter these cutoff points. We can execute this command, and we also produce a table with the percentages and the standard errors within each education system. And as we have done before with other analysis functions, you can also export the output into a file that you can easily open in any spreadsheet, because it's in a comma separated value format. I'm gonna run the same, well, it's not exactly the same because now I'm adding another grouping variable, which is the student sex. So I'm gonna calculate these proficiency levels by country and by sex, and I'm gonna export the output into a file that is gonna be called PEARLS benchmarks, and by default it will export to this directory, which is your working directory. If you do not specify any folder, it will always export to this directory. So I know I can go to my working directory, and as you see, a file has been created, and I can open it in my spreadsheet, and you have the output by each country, and also the student sex. For girls and for boys you have the proficiency levels and the standard errors.